Okay, we have page 482. And I think problem 8, that's where we got first couple problems done. It says how much money needs to be invested now to obtain $2,000 in 3 years if the interest rate in a savings account is 0.25% compounded continuously. And then it says round the answer to the nearest cent. So the continuous compounding formula is A of t equals P e to the r t. And they want to know how much needs to be invested to obtain $2,000 in 3 years. So the A of it's A of 3 years is $2,000, right? And they want to know the amount of money, so they want to know P. So what you do is you would have $2,000, and P is what you don't know. E and the interest rate is 0.025 because it's 0.25%, and then it's 3 years, right? So what you gonna do?
Give C by itself.
Okay, and you'll have to divide by that E, this E to the so P 2,000 and you can just put that in the calculator, right? So I don't have my calculator up. So it's 2,000. And it's so it's just divided by 5 second .0025 times 3. It's 1985.06. Okay. 10. Says May 31st, 2009, the annual percentage rate listed on Jeff's bank for regular savings was 0.25% compounded monthly. Use equation 60 to answer the following. If P is 2,000, what is A8? So the formula we're going to use is this A of P equals P 1 plus 0. R, I write the general formula, R over N to the NT. So for this specific value, you know, it's A of 8, and it's telling us P is 2,000, and it's 1 plus, and the interest rate is 0.25, so it's 0.0025, and then it's monthly, so N is what? 12 to the 12 times 8. So what I do is I just put it in the calculator that way. 2,000 1 plus 0.25 divided by 12. Now, as I'm entering it, I want to make sure that I'm actually telling the calculator to do what I want it to do. And that's still right. And then it's 12 times 8, right? And I've told it to do exactly what I want it to do. So 2,040, 40, right? To the nearest penny. And that was A, right? It says solve equation if A of t is 4,000, find t. So B, I'm looking at this formula right back up here. And it says A of t is 4,000, so I put 4,000 in there. And they want to know P. No. Solve the equation. 4,000 for T. So apparently they want to, the P is still $2,000 because they want to solve for T. So it's $2,000 is what your principal is. 1 plus, and your interest is still, and it's monthly, and then it's 12, and this is what they want to know. So how are you going to do that? You want to get your exponent, your exponential by itself on one side. So the first thing you're going to have to do is divide both sides by 2,000, right? So this is 2. 1. Now what are you going to do? Okay, do the natural log of both sides. Or you could do log base 10, whichever. But natural log is what they've been always saying. So do ln of 2. ln of this thing. 1 plus now what? 12t out in front, right? So this is ln of 2 equals 12t times ln of 1 plus 8. No. Okay, divide both sides by the 12, right? So the 12 goes out. And the ln of 1 plus see this would make, this would cancel out. That's just a number, right? And that would cancel out. So I'd have to do the same thing over here. I'd have to do 12 times the ln plus. And now I'd have t, right? T is by itself. I'll just put t on this side. I just got to do that ln of 2 divided by 12. So I'm going to have to do ln2, close the bracket, divide it by 12, and then I can just divide again, right? ln of 1 plus 0.0025 divided by 12 and close the bracket. Now I've told it to do the right thing, right? That is this. And I didn't have to bracket that 12 ln, that I could just divide it twice, correct? So I just enter it. 277, and let me see, what is it saying? The number of years, it doesn't tell me how close I have to get. 277, 29, so it's 277.29 years, right? To double, that's actually, because 2000 went to 4, so. And then the C part says, what principal should be invested? So if the account balance is 2,000 in 3 years. So now the principal is not 2,000. They're saying what 2,000 would give you. So if you got 2,000, write it down. If what they're doing is they're saying A of 5 is 2,000. So I would write 2,000. And they're saying what principal? So this is what I don't know. Times 1 plus 0.0025 over 12 to the 12, and it was 5 years. Like that, right? That'll give me how much principal I need to make $2,000 in 5 years. So what do I have to do with that? Divide this side by this, right? 1 plus 0.0025 over 12 to the 12 times 5. Or if you wanted to go 60, you could do it. So that means I have to divide this side by. So that, and that gives me P. Divided by 1 plus 0.0025 divided by 12. Bracket, and raise that to the 12 times 5, right? So I'd have to invest 1975.16. So that's the amount of money that I'd have to invest to make $2,000 in 5 years. The next one's kind of an interesting thing. It says a finance company offers a promotion of $5,000 loan. The borrower does not have to make any payments for the first 3 years. However, interest will continue to be charged to the loan at 29.9% compounded continuously. What amount will be due at the end of 3-year period? So the formula we use for continuous interest, A of T equals the principal E to the RT, right? That's the general form of the principal. Now the principal is 5,000, right? You can borrow for 5,000 at 29.9% compounded continuously. And it says first 3 years that you don't have to pay anything. You can just let it go. So what's the amount at the end of 3 years on a $5,000 loan? Continuously compounded at 29.9, so it's 0.299, and it would be times 3, right? You pay nothing on it for 3 years. That would give you the amount that you owe. Okay, so I go, and such a good deal they're giving you, 5,000. And then you have E, second, LN, of 0.29, what was it, 9? And then do times 3 years. Such a good deal. You only own $12,261. Right? They certainly gave you a good deal, didn't they? $12,261.18. And then at the end of 3 years, you can't pay it, right? So they say, well, we'll just let you go another 3 years, right? Just continue on. So essentially, you're doing A of 6, right? So you're going to do 5,000. You could either do another A of 3. You can either do it this way. Times 6. Or you could do an A of 3, with the principal of 12,261.18. E, I didn't leave myself enough room, 0.299 times 3. Yeah. Whichever way you'd want to do it. But if you did this, and you did it 5,000, second, E, 0.299 times 6, Now you owe 30,000. 67.29. $30,000. 67. So do you see why people get in trouble with their credit cards? No, they could have avoided that whole thing if they'd have done one thing. What's that?
Pay it off and
Pay the interest every month, and then they'd still owe 5,000 at the end of 6 years. Every time they got their bill, if you just pay your interest, you'd maintain 5. Now you'd have all your interest costs on that 5, but you wouldn't have this you'd save money because you wouldn't have interest on interest on interest. You'd save that. And that's exponential growth. And if you look, credit card companies charge you that kind of interest, don't they? But probably not, I don't know whether they charge continuous or not. Okay. 14 through 18. It's radioactive isotopes, and they're giving you the formula there. AT equals A0E to the KT. Initial amount of material, and K is the constant of decay. So 14. It says cobalt 60 used in food irradiation. Initial amount 50 grams. Half-life of 527 years. The first billet says find the decay constant. Round your answer to 4 decimal places. So the formula we have is A of T equals A0 E to the KT. So they want to know what K is. It says, and notice it says the half-life is 5.27. So if you started out with 50 and you did it for 5.27 years, you should end up with how many grams? Half of 50, right? So see, if you did an A of 5.27 years, you're going to get half of 50, you're going to get 25. So what you do is 25 is equal to how much you start with. E and K you don't know, and T is 5.27. See, you see why? So this is actually 1/2. You divide both sides by 50, right? Equals E to K 5.27. Now if you look at, I kind of got it squeezed together, but if you look at this isn't the answer. But if you look at that, how are you going to solve for K? What?
Do an actual log.
Okay, do an ln of both sides. So you do ln of 1/2 equals ln of E to the K. Well, I'll do K times 5.27. I'll do it the other way. 5.27 K. Now what? K, put 5.27K and put it out front, right? You,
Divide it by everything, okay?
okay, that'd be, just, why is ln of 1/2 equal to a negative ln of 2?
-1
Okay,
is up there, and
what you're saying is that this is actually ln of 2 to the minus 1, right?
yeah,
Put the minus 1 out in front, right? So you could write that. Then you could put the 5.27. Now, it wouldn't make any difference. You could do the ln of 1/2. And then that's ln of e. What's ln of e?
1.
Okay, so we have a minus ln of 2 equals 5.27K. So K is going to equal what?
3 natural log of 2 over 5.27.
Okay. Now I'm going to have to use this negative, right? ln of 2 divided by 5.27. Now I want to show you, if I did ln of 1/2, I'd get the same thing. So it wouldn't make any difference, you know, that minus. It just, so it's a negative 0.13. I don't know, did they have a certain number of decimal places? This one, round the answer to 4 decimal places. 1315. So that's K. And then the second bulleted point says find a function which gives the amount of isotope A which remains after T, keep the units A and T in the same given data. So all they're saying is put all this stuff together. So A of T equals A0, right? E to the constant of, is this minus 0.1315 times T. So this would be the general formula for that particular isotope. Then it says bulleted point 3, determine how long it takes for 90% of the material to decay. Round your answer to 2 decimal places. 90% of the material decays, how much is left? So if you have, this thing says that you have 50 grams to start with. So what is it asking for? 10% left, right? 90% decayed means 10% left. So 10% of 50 is what, 5? So it's asking 5 equals 50, the initial amount, e to the minus 0.1315, and what's the time it takes for 50 to go to 5? Okay, so what are you gonna do first? 550. So this is 1/10 E now just remember that well, okay, what are you gonna do? ln on both sides? Do natural log of both sides?
Yeah.
ln, and that 10 I could actually write like this, couldn't I? Isn't that right? ln this is a minus ln of 10, and then this is, bring that thing out in front, right? Negative 0.1315 t ln of e. So then t is going to equal what? Dividing both sides by that negative 0.1315, and you'd have a negative on the other side, so you'd have to just have ln of 10 over 0.1315, right? So ln 10. Point, is it 1315? 17.5. Years. That's not very many half-lives, about 3. I guess half of 50 would be 25, half of 25 would be 12 and a half, half of 12 and a half would be, yeah, it'd be about 3, wouldn't it? Half of 12 and a half would be 6.25. That'd be a little bit over 3 to get to 5. Logically. So, do you think you can do 15, 16, 17? You want to do another one? Okay. Never give Stacy an alternate or opportunity or something. So, this one, initial amount 75, half-life is 27.7, and find the decay constant. So once again, we're going A of t, this is the formula, e to the kt. So half, half is, you're going to have 2, right? Because you're going to have half of 75 and then you're going to divide it out. So it's all, half-life is always going to be a 2 here, and then it's going to be e to the k, and then the number here was 27.7. Is that skipping too much? Okay. So now what are we going to do? ln of both sides, right? Oh, half is going to be 1/2. Wow, I almost tried to skip a step. Right? Because it'd be half of the 75, and then when you divide 75 into it, it'd be 1/2. Well, ln. So it'd be the same thing. You could write it as a minus ln2 also, whichever way you wanted to do that. Then this on this side would be ln of e to the 27.7 k. So then you could take 27.7 k out front, and the ln e would just go to 1, right? So that k could equal negative ln2, or an ln of 1/2 over 27.7. Sometimes there's a danger if you skip steps that negative, you miss it. 2 divided by 27.7. Is that right?
Would you prefer us to leave it in fractional form or to?
I don't care. I just, if the answer is right, it's whichever way you want to do it. If you want to do ln 1/2, if you want to do all the steps, don't make any difference to me. Just if the answer is wrong, I can trace it back. I can figure out what you did and see where the error is. The trouble is if you try to skip steps like I've done, I have done it myself. You miss something. Like I almost got that rather than 1/2, had 2, had doubling, right? So now what we found is that this negative 0.025 is what we have for k. Was it 0.025, wasn't it? Yeah. Okay. So we found the decay constant. It says find a function that gives the amount of isotope A which remains after t years. So that's just substituting in A of t equals the initial amount that you have, e to the negative 0.025 times t. So that's the formula that you will work with. Then it says determine how long it takes for 10% of the material to decay for 90%. So this is when A0 is 75, right? So then 10% would be 7.5, right? So 7.5 is equal to 75 e to the negative 0.025 t. Then you divide that out. So this is 1/10, right? When you divide 75 into both sides. E Now you could write that as what? 10 to the minus 1. No matter which way you write it, what are you going to do now? ln on both sides, right? So you got, if I do it on this one, so this is going to be a minus ln of 10 equals, and I bring that negative 0.025 out the front t, and then ln of e is going to be 1, right? Do I have to write that down? No. Okay. Then I'm going to divide the t is going to be a negative ln of 10 over negative 0.025. So I can just do, when I do my calculator, I can just do ln of 10 over 0.025. 92.1.
That'd be in user.
That'd be years. T. What's it, does it say round your answer two decimal places? What was it, 10? What was that? Okay. Okay, 20. It says, example T11 in section 6.1, the exponential function. So this is what we had, v of x equals 25 4/5 of x was used to model the value of the car over time. Use the properties of logs and or exponentials to rewrite the model in the form v of t equals 25 e to the kt. So if you look back there, the change of base, it's if you have a base a to the x and you want to change it, and they're saying change it to e, then the change of base, I'm just going to go b x log b of a. So to do this, v of x then equals 25, and I'm going to change this to base e. So it's e, b is e, so it's b x ln, because that would be log b of 4/5. Use the properties of logs now. So that would be, this would be what it would be when you changed it to base e from base 4/5. 22. Says the diameter d of a tumor in milliliters t days after it is detected is given by dt So this is for cancerous tumors generally is what people are looking at. 15 e to the 0 to 7 t. So it has continuous growth. What was the diameter of the tumor when it was originally detected? Well, what originally detected is at time 0, right? So that's 15 e and it's 0. Well, e to the 0 is what? 1. So the diameter at time 0 was 15. So this particular tumor is that size. How long until the diameter of the tumor doubles? So this is another one. You know, you'd be the 30 equals 15 e to the 0.0277 t. This is going to be 2. And then you do what on that thing? Natural log of both sides. Then you bring that exponent down, right?
It's not 2 to half.
Doubles. This was doubling, not half. Right? It didn't say the tumor was shrinking. It said it was doubling.
I just didn't see how you moved over the 15, so that's fine.
What's that?
How you moved the 15 over.
Okay, now what are you asking me, Stacy?
On the, like, the sheet of B, it's 30 equals 15. You moved the 15 over, and I thought it'd be 1/2. You just got 2.
See, if it doubles, it goes to 30 from 15, right?
Okay.
So you divide by 15, and it's 2. If it went to half the size, then it would be 1/2.
Okay.
That's a decay. This is a growth. Okay. So then T is going to equal ln of 2 over 0.0277.
It's equal to 25.
25? Okay, I'll take your word for it. Keegan says he calculated 25 because Keegan wants to go. Right?
Magic beans here says
Huh?
magic on it and it shows me.
Okay. All right, that's it.